The objective that we establish is to create an Archimedes balance to practice the concepts of the buoyant force. We're going to prove the calculations of each weight that we're going to work with. In this case, it will be the weight of the beans and the weight of the rice. Also, we're going to take into account the weight of the mold. In order to make these calculations, we're going to fill a container with water to see how the buoyant force acts when we put the mold with the beans and rice.
To get the theoretical distance or height, we calculated the volume of displaced water needed to maintain a certain weight afloat. We used the buoyant force formula and calculated the volume displaced by the empty bowl, the bowl with 100, 150, and 300 grams. Since the bowl didn't have a shape that allowed us to calculate the volume easily, we used a measuring cup and water to measure milliliters and pour them into it. We then marked the water level on the bowl with the corresponding weight.
For the experimental height, we put the bowl in a bigger container filled with water, first empty and then with the three different weights. We compared the experimental height of the water to the theoretical mark, but since we don't have the displaced volumes at these heights, we couldn't know to how many grams it was equal to.
Our percentage error depended in the distribution of weight. The first two times we only put a single mark on the side of the bowl, and we didn't distribute the mass equally through the bowl. But in our third measurement, we made two marks, one on each side of the bowl, and also we made a pretty even distribution of weight. So in our third measure, the percentage error was very low. Also, the scale wasn't that exact. Also, we couldn't measure the exact volume of the bowl because of its shape. Due to that, we couldn't get an error percent.
The objective was fulfilled because we got the weight of the rice and the beans by applying the Archimedes Principle that was proved by putting the bowl in the water and checking the weights of each one given by the scale. We also got the buoyant force of the recipient and it helped us to understand more of this topic.
The Archimedes scale is a really easy and cheap way to calculate the mass of something, but it can be a little bit inaccurate depending on your measuring tools to calculate the amount of millimeters you will use on this. This activity was a good way to understand the idea and applications of the buoyant force.